Good afternoon, class. Welcome to the first day of calculus. So I'm gonna start off with a little simple question. Do you know what limit is?
This is Naya, and it's her first day of calculus. She has no idea what she's in for. Limits.
Okay. Alright. Good afternoon, class. Welcome to the first day of calculus. So I'm gonna start off with a little simple question. Do you know what limit is? No? That is okay. So does anyone know what calculus is? Yes.
I believe calculus is the mathematics of change. So it's like involving the math of velocities, areas, volumes, accelerations, and things like that.
You are exactly right. All our life, pre-calculus dealt with static numbers, but now that we're in calculus, calculus deals with numbers that vary. So I'm going to show you all a video that talks about and discusses limits and calculus.
Welcome to Calculus for Dummies. And in this episode, we're going to be talking about limits. So way back when we first learned the slope formula of a line, we learned that it was equal to the change of y over the change of x. But that was only true in cases where the function moved at a constant rate. Have you ever thought, what if the graph didn't move at a constant rate and it looked something like this? And the function was variable? How about something like this? Well, if you never even cared to wonder, luckily this guy did. His name is Gottfried Wilhelm Leibniz. So I'll start out by describing a classic calculus problem, the tangent line problem. Let's look at this graph of f of x. Say we wanted to find the slope at that point P. The goal is to find the tangent line of that point and find the slope, and that's what we're going to figure out how to do. So first, to approximate the slope, a line can be drawn through point P until it touches another point on the graph. Let's call this point Q. So if P was equal to C, comma, f of C, then that means Q would be equal to C plus delta x, comma, f of C plus delta x. Then, using the slope formula that we addressed earlier, the slope of that line would be this right here. F of C plus delta x minus f of C all over C plus delta x minus C. And this will simplify to this once the C's cancel out. So as point Q approaches point P, the slopes of the secant lines approaches the slope of the tangent line. The slope of the tangent line is precisely the limit of the slopes of the secant lines, which ultimately determines the instantaneous slope at the point P. So a limit is a value that a function approaches as the input, which is the secant line, approaches some value, which is the tangent line slope. Thanks for watching, and I'll see you next time on Calculus for Dummies.
Okay, so class, I hope that video gave you a better understanding of limits, and I will see you tomorrow. Don't forget, I will definitely be quizzing you on this, so go back and study.